take your time with questions like this. It's 7 marks, which means you have 7 minutes, really, to get your head around this and write out a solution. That's lots of time. So don't panic. Just highlight stuff as you go through and just try and get your head around it. It's known that 20% of plants of a certain type suffer from a fungal disease under normal conditions. So there's a proportion of plants that get a fungal disease normally, and that proportion is 20% or 0.2. That's also the probability of a randomly selected plant suffering from the disease. And that's going to be our standard, our P, which will be 0.2 to begin with. And then we take a sample, so that's going to be our N there, and we get our experimental result, 36 out of 250, and we have to just say whether that represents evidence that the probability has changed in some way, and specifically it's looking to see whether the proportion has been reduced, so it's a one-tailed test in the lower tail. Right, let's set this up. I'm first going to write down what we just identified about what P means. So I'm going to let P be the proportion of plants that suffer from the fungal disease. And then we can write down our hypotheses. So H0 is that P is 0.2 and unchanged. And H1 is that P is less than that, i.e. the proportion has gone down or been reduced. Okay, great. Now, we're going to create a random variable called x, where x is the number of plants from a sample that suffer from the fungal disease. And that particular x is binomially distributed. We've got 250 as our n, and a chance of success under H0 of 0.2. Success here is having the disease. You might not think of that as a success, but statistically that's what we're defining as success as here. Does it have the condition or not? Right, at this point I would recommend pencil or a different colour or something, just note, even if you just do it in your head, just note what the middle of the distribution is, the middle being the mean, and that's NP, otherwise known as the expected value from a binomial distribution. So just note in your head what's NP. It just helps you to sort of think and help you to visualise what's going on here. So I've written here, note that NP, which is 250 times 0.2, is 50. So that should be our expected number. If you take if H0 is true, and that P is indeed 0.2, if you take 250 plants, a random sample of 250 plants, you'd expect 50 of them to be diseased. Now what have we actually got? We've got only 36. So we need to now write down the probability, work out the probability that x is at least as extreme as 36. Never just do an equals here, ever, 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 never do that. It's always at least as extreme. Now, since 50 is the middle, 36 is in the lower tail of the distribution, and we need to be at least as extreme as that. If not 36, then more extreme, which is even less than 36. Work that out on your ClassWiz calculator, and we get 0.01389-ish. Compare that now explicitly with the significance level. It's clearly less than that, so it's unlikely enough for us to reject H0. So that's indeed what we do. We're looking to see, is this so unlikely, using this as a threshold, that we can reject H0, and indeed we can. And we're almost done. We just need a conclusion in context. Talk about evidence. There's evidence at the 2% significance level that the new method reduces the proportion of plants that get the disease.